Let's take a look at another example of how we can use the basic mathematical high-low method to calculate a set of mixed cost, to break that set of mixed cost down into its fixed and variable components. We have an example utilizing a machine shop, and the example shows us that the highest bill that they incurred happened to be $2,600. It occurred in August. Let's just do some highlights here. Their highest bill was $2,600 that occurred in August, and when that occurred, their machines were running 1,400 hours. So why are we looking at utility bills and machine hours? This is what is driving those costs for utility bills. Utility bills has a fixed component, a variable component, and we want to be able to separate those. Okay, so now we have the highest cost of utilities during August. We have the lowest bill that we paid for utilities in December, and our machines only ran 900 hours during the lowest month. So in order to calculate the variable cost formula and the fixed cost tied to these utility costs, we need to have some type of relevant range over which these costs are occurring. And so that is why we have looked at the 12 months for this machine shop's particular time period, identified the largest amount of expenses that they've covered and the lowest amount of expenses that they've covered, and this gives us a relevant range and a relevant range time period wise and a relevant range cost wise to analyze for this particular situation. So if you remember to our instructions, we want to take the change in total cost, $300 between the highest and lowest utility bills. We take the change in our units of activity, which are our machine hours. And so in the month where we paid the highest utilities, we ran 1,400 machine hours compared to 900. In the month when we ran the lowest amount of utilities, and so the difference is 500 hours. If we calculate if we do our math here, $300 divided by 500 machine hours gives us 60 cents per machine hour. Okay, we can do the math. This is basic math. But what does this mean? Okay, 60 cents per machine hours tells me that every hours that my machines are running, they cost me 60 cents per hour in utility cost. Okay, so once I know my variable cost, I can figure out my fixed cost, which is what the problem asks us to do next. If I know my total cost for the period, and we do, okay, in this particular situation, we can use, it doesn't matter, we can use the 2,600 or the 2,300. If you were given a list of items to choose from and you had to choose the highest month and the lowest month, then when we calculate fixed costs, you simply need to use one of these amounts, the highest or the lowest. It doesn't matter which one, because the 60 cents per unit will not change regardless of of the total amount that we have spent. The 60 cents per unit as a variable cost does not change. So in this case, they've used 2,600. That's what we will move with. So if we take our total cost of 2,600 and we subtract our variable cost, how do we know what those are? Well, we've determined that it's 60 cents per machine hour. And my machines during the month when we incurred 2,600 in utilities were running 1,400 machine hours. So 60 cents per hour for 1,400 hours is $840 in variable cost for that particular month. Okay, so if I take my 2,600 less, these are my total costs, less the variable costs for that month, it shows me that what we have left are our fixed cost, $1,760. Now, since we're doing this monthly, it means that every month my fixed cost will be $1,760. Okay, and every month my variable costs are going to be 60 cents per machine hour times the number of hours that my machines actually run. Okay, so now we can determine a formula that we can use in the future to predict what utility cost might be. So if I want to know total utility cost, it is simply going to be what is 60 cents per machine hour times the number of machine hours that we think we're going to run in that particular month, add to that your total fixed cost, and this is the estimated amount of expenses that we will spend on utility cost in any given month, based on the high-low method and a relevant range that covers our highest cost and our lowest cost. So requirement 3 says, okay, let's do this. Can you predict what utility cost will be if we run 1,000 machine hours in January? Yes, we sure can. 60 cents per machine hour times the 1,000 hours that we think we're going to run tells me that my variable cost will be $600. I will add to that the fixed cost per month, and that gives me an estimated utilities for the month of January of $2,360. Okay, once again, it's just an estimate, and our estimate is only as good as the data that we're using to create that estimate. But I can use, once again, this simple, basic mathematic formula to predict what utility costs should be for a month, a quarter, semi-annually, annually. Okay, there are other more precise measures that we could use, statistical analysis using regression. But this is one of the easiest and most basic ways that we can use to simply plug a formula into Excel and calculate what our cost should be for a particular month. And as we move through these lectures, you'll see how important it is to be able to separate fixed from variable cost in decision making in the future.